So today's session is going to be an introduction to Python for data science and machine learning aspirants. So to start off the session, as a language, Python has many, it's a very versatile language, a very versatile programming language. Unlike many other language we have used or come across so far in the last few decades. So Python's versatility is more prominent in the machine learning, data science, deep learning, such kind of domains, but it is equally versatile and upcoming in the domains of web development. It has a framework, a very strong framework called Django. It is also very popular, getting very popular in the traditional application development areas, including various use cases in IT security and all other different types of corporate and enterprise application development. Now today's session is going to make a specific focus on Python with respect to data science and machine learning applications of Python. We are not going to deal with aspects of Python which are related to web development or which are related to traditional enterprise application development, etc. So we will focus on data science and machine learning related aspects. Now, what are machine learning or data science related aspects? Let us look at that. Look at as to what we are going to cover with respect to Python's flavor in terms of data science and machine learning. We are going to look at a slide from this PPT, and we are going to do all practicals after that. We're going to look at the data science machine learning process flow. Okay, and in that process flow, we will understand as to how and where in the machine learning, artificial intelligence, deep learning, etc. domains, Python is used predominantly. Okay, then we are going to look at some applications of Python, and after this process flow, we are going to get into coding. We are going to look at various applications of data acquisition using Python from different sources. We are going to look at various internal data types that are offered by Python, and we are going to have a small introduction about Numpy and Pandas libraries. Numpy for array management and Pandas library for series and data frames. We will also look into file handling and database handling using Python. Okay, so this is going to be today's agenda. The broad process flow of data science and machine learning are largely same, so we have not segregated them, although data science and machine learning have subtle differences, but from an understanding point of view, we will perceive for this presentation that they have the similar process steps. So the starting point is your data sources. Now, what are your data sources? Your data sources can be varied for your machine learning or data science project. It can come from a variety of different sources. It can come from within your organization. It can data can be derived from different sources within your organization. So those can be your input sources as well. Data can come from various external sources. Let's say, for instance, you are working for a fund management company or a stock broking company, and you do a lot of analysis on stocks and fund trends. Now you need a lot of external data in terms of asset values of those stocks, or asset values, or net present values of stocks, or present values of funds, etc. Right. So so what I was mentioning is that it can come from a variety of internal and external sources. Now the other aspect of your input data it can come in a variety of technical formats. So it can come from database table. So maybe you have a data warehouse or a data lake, in modern terms what is called a data lake, or you can have your own functional systems, and data are residing in those functional system in terms of database tables. So those can be your input data sources. They can come from flat files. There can be a, let's say, nightly feed from one of the departments to your organization, to your department, to your data science department. In terms of a flat file, they can come as Excel files, so they can come as CSV files, separated values. They can come in terms of XMLs or JSONs, etc., etc. So you have possibility of a variety of technical input types. Okay. Now, having said that, now that you have determined what are going to be your input data sources as to where data are coming from, and you have also determined as to what formats the data are coming to you, you set up a data collection method. So based on what template, what format, or what sources and etc. the data are coming as and from, you set up those scripts for data collection, and you probably have set up a data science repository, or your project's data science projects repository, unified repository, where all incoming data are going to get gathered. Now, once the data are collected, you go through a series of processes which are again, it has different names. I mean, some people call it exploratory data analysis, which is probably a more superset term. Then this exploratory data analysis are also contain a number of different steps, possible steps. I mean, some steps are going to be applicable to your project. Some steps may not be applicable to your project. So it involves feature extraction, data analysis, visual analysis, univariate analysis, bivariate analysis, multivariate analysis, etc., etc. It'll also have feature extraction. It'll also need data structuring, cleaning. You may have erroneous values in your data. You may have missing values in your data. So it has to go through cleaning. It may have certain fields that need to be enriched, certain types of transformations. And also when you do all those things, you also need visualizations for your data, the analysis that you're doing. As final output, you also need powerful visualization. So these are all steps that are going to be part of your exploratory data analysis. And so those transformation steps, or cleaning, structuring, feature extraction steps, those are lovingly called data wrangling or data munching. There are a number of different terms that are used in the industry. So based on your context, you can use a terminology that best suits you. But these are broad steps that are followed during after data collection. Now, why are these steps followed? These steps are followed to perform, or rather say that to transform the data in a shape which is which can be ingested by your predictive algorithms or machine learning algorithms. Okay, so at this step, based on your business case or business problem that you are set out to solve by your data science or machine learning project, you would have also determined what kind of algorithm you are going to use, right? So based on the chosen algorithm, and in some of the cases and many cases, you may have a variety of choices, and you may have to kind of train and test and figure out which model is, or which algorithm is working best for you. All right, and based on the algorithm and the type of problem you are solving, the data transformation and data structuring, cleaning needs are going to be different. So the purpose of your exploratory data analysis, wrangling, munching, transformation, whatever you call it, is to make the data suitable, because you have collected a lot of data and there is a lot of garbage, and there are a lot of irrelevant data, and there are a lot of data which are not in the form that your machine learning or data science algorithm needs it to be. Okay, so once that data transformation phase is done, you have a chosen algorithm based on your business problem. You go through a process called model training and model optimization. Okay, so now you have the data, you feed it into the ML algorithms, and that ML algorithm is going to read through the data, and normally for data science machine learning projects, it has to be a voluminous data, a lot of data. So it trains the model from the data. It basically finds out patterns and relationships within the data, and creates a model that you need. Right, and while doing that, there are certain steps like cross-validation, etc., CV steps, etc., which and hyperparameter tuning, which are performed to optimize the model, because you can't expect that okay, you feed the data and train the model and everything is going to be hunky-dory and you are going to get the perfect result. That doesn't happen. You go through a series of steps and iteratively you find out what configuration of the model or what hyperparameter construct are best suited for your model. So you may need to tune the data, you may need to tune your hyperparameter, you need to perform lots of iterations using cross-validation techniques, etc. So the optimization happens. And once your model is trained, you are happy with the results, you deploy it in production. Once you are deployed, you can't forget about it. You have to continuously monitor the results of the ML models or predictive models. And then periodically, you have to make sure that you keep your model updated, because as your organization is producing new data over time, over weeks or months or years, I mean, it certainly not years, over several weeks, your model is going to be out of date because it has not ingested or updated with the new data that your organization has produced. All right, so continuous periodic update of the model and redeployment is also necessary. So this is broadly what the process of machine learning or data science projects are. Okay, so these phases are more directly related to data, processing of data. These phases are more related to model and training of algorithms, or using algorithm, choosing the right algorithm and training the algorithm to create the models. And this is your production activities. Right, so in this phase, what we are going to focus on today is this part, okay, the data collection, the data exploratory data analysis, wrangling, munging, etc., this part. And we will see some of the features in Python to see what kind of features Python provides on this part. And mind you, by not focusing on this part here, model training and production, we are not missing anything today, because most of your work in a data science machine learning project, at least 60 to 70% of your work in a data science machine learning project, are going to involve these steps of finding out the right data sources, setting up collection methods, and performing your EDA, wrangling, munging, etc. Okay, so with that, we will move over to the coding part. Okay, so we are going to show you a couple of things. One is I have two coding files which are basically Anaconda Jupyter notebooks. So if you are not familiar with Anaconda Jupyter notebooks, Anaconda provides a host of softwares for Python development. It provides IDEs, and it also provides a very popular tool which are used by Python developers or Python learners, etc. Not only learners, I mean professionals also use Jupyter notebook very frequently. Jupyter notebook gives you a segmented construct for writing code and testing them. It's not something where you write full codes, full programs, Python programs. But if you want to learn, or if you want to go through a step-by-step process of development of your program, then you can use Jupyter notebook. So I'll strongly recommend that instead of writing full programs of Python at least during your learning process, definitely always use Anaconda Jupyter notebook. I mean, it has become so popular that almost everyone learning data science, machine learning, Python, etc. are using Jupyter notebook for that. All right, but when you are writing production programs, you need a proper IDE, integrated development environment, like Spider is an IDE that is provided by Anaconda, or for instance, PyCharm is offered by JetBrains. These are very popular IDEs for Python development. So for production systems, you can use those IDs, but definitely for learning purposes, you can, and also testing and development purposes, you can use Anaconda Jupyter Notebook. So what you have to do, basically, you have to, if you're not familiar again, you have to go into the Anaconda's website, and you have to install Anaconda in your machine, and then it's a pretty intuitive process, and it'll guide you through the process. So pretty easy. Okay, so I am using this Anaconda Jupyter Notebook. So as I was saying, I will show you two Jupyter Notebooks. In one, I will show you some code about Python's internal data structure, a little bit about Numpy arrays and Pandas series and DataFrame. Now, just to remind you that you may have received a mail from us also that next week there is a detailed session on Numpy arrays and Pandas series and DataFrame objects, which are very, very important Python libraries for data management. And as I said, that data management or data manipulation EDS steps, they comprise of about 60 to 70% of your data science machine learning projects or initiatives efforts. Okay, so the other Jupyter Notebook that I'll show you deal with how Python is used to handle files, so reading from files and writing into files, etc., and then how we can work with RDBMS tables. So I have a small little MySQL database and a student table, and we will see with some basic coding as to how we can read data and write data onto tables. Okay, so with that, let's get started. So first thing, when we are dealing with data, obviously the first thing we have to learn is what are the different types of data that Python offers. Any language when you are learning, one of the first things you learn is what are the data types that language offers. So Python as a language is dynamically typed. What do you mean by dynamically typed? Dynamically typed means that if you are exposed to Java is a strongly typed language. So what that means, that for using a variable, you have to declare it first. Unlike Java, Python, as I'm saying, is dynamically typed. So that means you don't need to declare a variable with its type before using it. Okay, a strongly typed language needs a variable to be declared before any assignment into that variable. That means that once it is declared, its type is cast in stone for the execution of that program. But that is not the case in Python. So what we are saying is, we will come to it in a moment. In terms of variable types, there are these key variable types. We have integer, we have float, we have boolean, we have string. So these are some of the variable types we will work with. So these are pretty intuitive. Integer is of course for storing integer values. Float is for float values. Boolean is a true and false value. I mean only these two possible values. And a string is obviously any string value. Okay, either character or string values. So you can use variables like this. There is no declaration of variables in Python. So I equals to 5 creates an integer type variable. So Python looks at this statement and sees that, okay, an integer value is being assigned. So that means that I have to create I as an integer variable. Okay, print is used for printing anything. Right, here is a string variable. Okay, so this is what it is printing. So of course you are okay. So these are pretty intuitive, no big deal. So it's printing the values of each of the variables that are assigned here. So float, when we print this variable, it prints the value assigned to it. Okay, so what I was saying is that it's dynamically typed and it doesn't need a declaration. So a test for that is this. So what we are doing is we are assigning 5 to I. So that means it's Python is creating I as an integer variable. And then I'm printing it and it's printing 5. And then I'm saying I equals to change to a string. Now Python has absolutely no problem if you try to do that. Although the value that is existing in I is 5 already, when you try to assign a value of another type, it has no problem. It has changed the type of the variable and it has printed it. It has stored it and printed it. Okay, so this is an example of, and this kind of operations are not possible in strongly typed languages like Java. There's a simple example of conditions. You have x and y, 7 and 9, and you are checking for equality, and of course it is going to print unequal because they are not equal. Now there is one point about the syntax of Python here. These are starting statements of a block. Okay, so condition or iterations are blocks. Okay, now when a block, when there are blocks, there are starting statements of a block, and then there are statements within the block. So this print statement or this print statement is within this block, and this print statement is within this block. Now one thing about syntax about Python is that the starting of the block will always end with a colon, and the statements within that block have to be properly indented to the right. Now in other languages there are no such requirement. Okay, so even if you do this, it is not a problem in Java. Okay, or in any other language. Java already also has this curly braces from which it kind of determines what statements are within a particular block, but there are no curly braces here. So the indentation actually ensures that what statements are part of a block. Okay, so if you start the print from the same position as the starting of the block, that is here, it is not going to take it as a statement which is within the block, right? So in case of Python, the indentation is a syntactical requirement. It is not a cosmetic requirement. In other language, in most other languages, indentations are cosmetic requirements for better readability. Because when we started coding, we were taught as to you have to properly indent your code, but those were always visual requirements, cosmetic requirements for better readability. Of course, those also need to be complied to, but in case of Python, it's a syntactical requirement. It's not a cosmetic visual requirement. There is an example of iteration that we have put in here. So one of the commonly used, there are other types of iterations also, but we have just for the sake of this intro session, we have picked only this couple of examples and not everything. And there are a lot of other operations on the elementary data types or Python's internal data types as well. We haven't gone through that. In our Python course for which are embedded within the data science or machine learning, there are about 300 odd code pieces that we demo for teaching you all the data structures. So there's a simple example of an iteration. Now iterations use either conditions or iterables. Okay, so what we mean by that, this is an iterable. What is this? This is a list object. Okay, so there are we will get into lists in a moment, but just for now let's understand that list is a collection object and it can hold multiple values. It's like an array. Okay, a special type of array. Okay, so we have three elements in the list in this array, which is called a list. Lists are normally enclosed, the elements within a list are normally enclosed within square brackets. Now any collection object is an iterable. What is an iterable? In Python, an iterable is an object through which an iteration can process element by element. Okay, so now for is an iteration statement, right? And this I'm saying is a list which is an iterable. So what this for loop is going to do is that it's going to iterate for 3 times, that is the number of elements that this list has or this iterable has. Okay, and during those 3 passes of the iteration, it is going to pick up the subsequent elements. Okay, so first time it comes into this for loop, it'll pick up Sunday, next time Monday, next time Tuesday, and it's going to print all of them. Okay, so this is a very simple case of an iteration using an iterable. Now there's one other simple example of the for loop, is that the range function also returns an iterable. So what does it return? The range function with a value passed to it returns a range of values starting from 0 till to that number. Okay, to that many number of items, actually, not to that number or till that number, that many number of items. So range 5 is going to return an iterable which will contain 0, 1, 2, 3 and 4. Okay, 5 numbers. And in each pass of the for loop here, it is going to extract 0, 1, 2, 3 and 4 each time. So this is what is printed by the for loop. If you are familiar with the iterations from other languages, print the value of the current value that is extracted from the iterable. So let's say 0 is extracted and it prints this, and so on. Okay, so this is another simple case of an iteration. Now one thing is very important. Again, we briefly describe each of these type of objects in Python in this session. There are 4 different types of collection objects in Python: lists, tuples, dictionaries and sets. Now lists, tuples, dictionaries and sets are collection objects that are offered or inbuilt within Python. Okay, the standard installation of Python. Now they are different from arrays or series or data frames in the sense that arrays and series and data frame objects are external to the standard installation of Python. They are part of external libraries. Okay, so we will look at them separately. Now what are collection objects? Collection objects are normally those objects which contain multiple elements. Okay, so all these elements like dictionaries, sets, tuples, lists, and also in Numpy and Pandas, series, data frames and arrays, they are all collection objects. They hold multiple elements. Now there are differences between all these different types of collection objects. We will see one by one. So list is probably one of the list complex of them. No big deal about them. It's like an array. Okay, and you represent list enclosed within the elements separated by comma and enclosed within square brackets, and the list elements can be accessed, and list elements can be that you can create contiguous slices or access contiguous slices of elements from the list, or you can access individual elements from the list, etc. etc. You can use list as an iterable with for loops, etc. So those are all are possible. You can change individual values, you can change multiple values within list, you can append the elements in the list, you can delete elements from the list. So standard array, like we may have seen arrays in other languages, so all those operations are possible. Now we will not go into all of those functions here, but probably go through a couple of examples, simple examples. So how do you create a list? Simple way is by assignment within square brackets. So list of elements separated by commas enclosed in square brackets, and that creates a list. We will see an example of how you can access a cross section of a list with stride. Okay, so what does it mean? It means, okay, so first let's look at what is a list that we have created. 1, 2, 3, 4 and continuous numbers till 14. So 14 elements in the list called list 1. What I want to do now is that take this list and I want to extract elements from this list starting from the second element of the list. Okay, so 0 is the first element and 1 is the second element. So starting from the second element of the list till the 12th element of the list, each time skipping by 2. So this is the stride value. So this is the starting index, this is the ending index, and this is the stride value. Okay, so you are extracting a slice from the list but with a stride value. So what it's doing is it's picking up, so it starts from the second element, so it picks up 2 because stride is mentioned as 2. It picks up 4, 6, 8, 10 and 12, and it has reached the 12th element and it dumps it, stops. Okay, so if you don't use the stride value, it will give you these elements. Because you have mentioned the stride value, it skips a number in between. Okay, so this is one example of how you can access lists. Then there is a simple example of how you can append an element or a bunch of elements after a list object. So we create this list object 1 to 10, so 10 numbers, and then what I want to do is that I will have a sequence of numbers 0, 1, 2, 3, 4, 5 numbers, which I can generate by using this statement, range function, using 5 as a parameter to the range function. And I want to append that bunch of elements at the end of my original list object. Okay, so that I can do by the append function. Now append function in this case is appending one element at a time. How do we know that? Because we have used it within the for loop. So what is range 5 returning? The range 5 has returned this, and this is an iterable. So this loop is going to iterate for 5 times. The first time it is going to extract 0, second time x's value is going to be 1, third time 2, fourth time 3, and so on. And each time it is going to append one value at the end of list 1. And when you print list 1 at the end of this loop, you have this, what you wanted to achieve. Okay, so this is another example of how lists are amended. Okay, right, now tuples. Tuples are similar to list objects. They also contain list of values similar to the list object. The big difference between one is a syntactical difference, which is probably not that significant a difference. In case of lists, we use the square brackets for enclosing the elements. In case of tuples, we use a round bracket. That's just a syntactical difference. It also can contain multiple elements, as many elements you want. The big difference between list and tuples is that a list is a mutable object, tuple is not a mutable object. So that means that once a tuple is created, you cannot change it. Okay, so tuples are used in cases when in your program you want to have a list of values, but you do not want your programmer, or if you are the programmer, you do not want the program to inadvertently, by some coding mistake, change the values in the array. Okay, so if you have a situation like this, that you do not want, you have a fixed set of values and you want to keep it fixed throughout the duration of your program, you use a tuple. You don't use a list, right? And a list is, as I said, it is mutable. So that means that you initialize a list object with values, and after that you can do whatever you want to do with it, change it in whatever way you want. But that is not the case for tuple. Some ways of how we can create a tuple. We can create a tuple by passing a list of values. So we are creating a list first and then using the tuple function to use the list object that creates a tuple object. Okay, and after we print it, what is printed? It prints this. So these are the elements that when we see the round brackets, it means that it's a tuple, it's not a list. In the second example, you are creating a tuple from a dictionary object. So what is a dictionary object? Actually, I probably should have shown this example after going through dictionary. Okay, so dictionary objects are also collection objects, but quite different from list and tuples. List and tuples are kind of list of values, but a dictionary is a key value pair. So you can have as many number of key value pairs in the dictionary, but they are key value pairs. One thing about dictionaries is that the key names cannot be duplicated. Okay, you cannot have the same key name appearing twice in a dictionary. All right, so here we are creating a dictionary, and again syntactically dictionaries are enclosed, elements in a dictionary are enclosed within curly brackets, and the elements are separated by comma like other collection objects as well, but the elements have this construct. Each of the single elements have this construct. The key name, which is name here, followed by colon and followed by the value for that particular key name. Okay, so here in this case we are creating a tuple from the dictionary name, and this is what is created. Now this is very strange. What is strange about this? The strange thing about this is that a list is a list of elements, and it's almost same as tuple except for the difference of the syntax of curly braces versus round braces, and mutable versus non-mutable. But dictionary being different, they are pairs of keys and values. So when the tuple is created from a dictionary, does it take the key names or does it take the values? Okay, will it take name and salary, or will it take Robert and 2000? Because name and salary are key names of the dictionary, and Robert and 2000 are values in the dictionary. Turns out it takes the key names. Okay, syntactical. All right, so you can also create a tuple from a string. This is also an interesting case. All right, a string normally, okay, I'm saying Cristiano Ronaldo, it's a string. Now normally tuple, you have seen by definition is equivalent to a list of elements. Okay, it's like a list. Now Cristiano Ronaldo is a string and as a single element, and it is not a list of elements. Definitely does not appear like a list of elements. I mean, but it's a list of elements from the angle of it's a list of characters. Okay, so you can perceive this string as a list of characters, and that is what tuple function translate the string object as. Okay, so when you pass a string to create a tuple, it breaks it down into individual characters and creates a tuple which is comprising of all the characters, including the space in between inside the tuple. Okay, pretty interesting. However, there are definite cases of that. When you learn applications like natural language processing and data preparation within the applications of natural language processing, then you will come across a situation where you need to break strings down into, in certain specific application, you may need to break strings down into individual characters. Now, how do you access? So we have seen an example of accessing slices from a list, and here we will see how to create a slice from a tuple, and essentially it's the same thing. So when you say tup1, which is tuple name, and provide the starting and ending index, you will get that slice. So that means 1 starts from the second element and go on till the 5th element. So I'm supposed to get Gilchrist, War, Dravid and Polak, and it is returning that. Okay, this case is interesting. As the starting index, you are not mentioning anything, and in this case, the third case, as the ending index, you are not providing anything. That means that it is going to take the default value. So when the starting index is left blank, it starts from the first element. So it starts from the first element, so it picks up Gale as well. And in case you are not mentioning the ending index, it is going to go on extracting the elements till all the way till the end of the tuple. Right. So that's a bit about tuples. Working with dictionaries. Dictionary, as I mentioned, we'll skip through quickly and probably look at this example of iteration using dictionaries. So dictionary, as I mentioned, are key value pairs. So I'm creating a dictionary like this. So there are keys, tran ID, so transaction ID, cust ID, account type, amount drawn, etc. So it looks like a financial transaction. So transaction ID, customer ID, so means you have some values. Now what I want to do is I want to print all the key value pairs from the dictionary. Okay, so how do I do that? Again, dictionary is a collection object, it's an iterable. So I can use a for loop just like I've used in case of a tuple or a list, and use dictionary as an iterable. So I say for x equals to dictron, and it is going to go through all the key value pairs in the dictionary and pick up the value in x. No, sorry. That is the trick here. When you use a for loop with a dictionary in x, it extracts only the key name. It does not extract the entire key value pair. It does not extract the value. It only extracts the key name. All right. So each time when I say x, it prints the key names. It does not print the values. Now I have to explicitly extract the value from the dictionary by using the dictionary name and in subscript or in as an index providing the key name. So this is another way of accessing your specific dictionary elements. So use the dictionary name within square brackets as an index. You provide the key name of the dictionary and it extracts the value against that particular key name. So the first time this for loop works, x's value is tran ID, the first key name. And when I say in the print statement, when I say dictran, x translates to tran ID. So dictran tran ID, it fetches this value and it prints it here. So this is unlike the other collection objects, list or tuple, that we have learned here. There is possibility that you may make a mistake in mentioning the key name in a dictionary. So if it is all done dynamically within your program, and let's say you are writing a dynamic program where you are generating or you are assigning the key names to a variable and using this variable to extract values from the dictionary. So something may go wrong and your key name that your program has generated may turn out to be wrong, and in those cases your program will throw an error, and you can trap that. You can use a try error block or try except block in Python, and within the try you execute your commands that you want to execute, and you catch a key error. You catch the key error. So that means from the try block, if any of the statements is throwing a key error, and that happens when you mention a wrong value against your key name, it will do what you have done in the key error block, sorry, the catch block or the except block in this case, or exception block. In I think in Java or C++ it's a catch block, and in Python it's an exception block or except block, right? So in this case what we have done is we have passed a wrong key name which doesn't exist. It's account type, it's not account type 1, and of course it cannot work, and it did not go through the rest of the statements in the try block, and it has printed key specified is not found in the dictionary, right? So you need to do that in case of dictionaries. Sets are again interesting ones, and here for working with sets, they're quite different from the other collection objects that we have learned so far, in the way that they are aligned to the set theory that we have learned in our schools. Okay, what are sets? Sets are sets of values that are unique in nature and that are not ordered. Okay, in set, elements can exist in any physical order. You do not have any control over the order, physical order of elements in sets, and they are unique. No element in a set is duplicate. Okay, so if you add duplicate elements in sets, it is going to retain only one value. So these are characteristics of sets in terms of what it can store, and in terms of what it can do. If you remember the set theory in our schools, we used to perform union operation or difference operation or intersection operation or symmetric intersection operation, etc. And the same thing is possible with sets in Python as well. So we have intersection function with which we can find the intersection of two sets, and we are running short of time, and I will skip the explanation, but for your advantage probably look up what is an intersection operation or what is a union operation in set, and we can perform the intersection operations, difference operations, etc., or symmetric difference operations, etc., using our set objects. Right. Similar way we can iterate through sets as well. Again, as I said, that physical order is not in your control in sets. You can see that we have created a set in this physical order with elements in this physical order A, B, C, etc. But when you print that within a for loop, the physical order is different. Okay, but that's not the case for dictionary or list or tuple. Okay, we'll take a glimpse through the Numpy library. When you talk about data science and machine learning, there are a lot of application, be it business application or be it applications, be it applications involving business generated data, or be it applications using textual data or image data, etc., or sound data, noise data, etc. There predominantly we will put 80 to 90% of our focus on managing all this data in numeric form. Okay, so there may be some categorical variables, but all your algorithms require your data, or most of your data, to be in numerical form. And a lot of this data management will be in terms of managing them as array constructs. Okay, so understanding the management of array constructs is very, very important, because your applications, data science and machine learning applications, are going to be full of array management, series management, data frame management, etc. So these constructs are very important. So what are arrays? Arrays are again collection objects. However, they are not inbuilt collection objects to Python. The arrays are part of a library called Numpy, and all the array management features come from the Numpy library. So here we have to import the Numpy library, and this is an alias that we have used. There's a commonly used, conventionally used alias, Numpy as NP. We can create arrays, multi-dimensional arrays, and one thing about arrays is that They can be multidimensional. They don't have to restrict within 1 dimension or 2 dimension or 3 dimension. They can be X dimension layered. So here in this case, we are creating a 2-dimensional array. So essentially passing 2 lists to create it, and with the array function, it is creating the array. And when we print it, it prints this. So that means it's a 2 by 5 dimensional array. Okay, so there is a attribute of array objects called shape, and you can find out what is the shape of your array. There's a lot of cases that you need to change the shape of your arrays. There's a lot of cases. Say for instance, you are getting some image data. Now you are getting image data as flat arrays, okay, for your machine learning purposes. However, for visualization, you need to reconstruct those arrays in the shape in which they represent the image. So if the image is from a 8 by 8 pixel matrix or pixel grid, so then it's naturally a 8 by 8 array that the data came from. However, for your predictive modeling purpose, what we do is later on we flatten the 8 by 8 matrix to 1 by 64 or 64 by 1 dimensional array, and feed the flattened array to the machine learning algorithms. Okay, so there is a need to shape and reshape back the arrays into different dimensions, and that is why this reshape command or reshape function exists. So what we are doing is we are creating a flat array using the arange function from, again, Numpy. It returns an array of 1 dimension of 30 elements. Okay, it returns a flat array. However, I further apply the reshape function to transform that flat array of 64 elements into 5 rows, 5 by 6 grid. Okay, which is what this is doing. Now this is how you can also iterate. It's more like iterating through lists or sets, etc. However, in this case, a matrix that we have created or array that we have created are 2-dimensional, and each time you iterate through an array, it picks up 1 row. So the iteration that we have seen in the examples of set or lists, it picks up 1 element because we created them as 1-dimensional. In this case, it picks up 1 row at a time. And here is an example of how we can take a. So this is picking up row subsets, and in this example we can pick up a column subset by using the total number of columns and processing 0, 1, 2, 3, 4 to the number of columns that the array has, and using n as the column subscript or column index with the array name. So that means that leave this part blank. That means it picks up all rows of the nth column. So when n is 0, pick up all rows. This statement means pick up all rows from the array of the nth column. So that is first 0th column, second, 1th column, that is the second column, then the third column, etc. Okay, so this gives a row subset, and this gives a column subset. We will share the recording back. If I'm going too fast, you can play them back and learn them a little bit. We'll skip a bit and show you a glimpse of series objects. So we will go through them in detail in the next week's session as well. But just as a glimpse, they are part of the Pandas library, the series and DataFrame objects. Sorry, this comment should have DataFrame. Okay, just one moment. Okay, so again, we can create a series object. Series is 1-dimensional, and DataFrame is a similar data object, which is multidimensional, or rather two-dimensional. So series has only, you can perceive it as row or column or whatever, and data frames will have rows and columns, right? So how can we create a series? We can create it from a list. Here in this case we are passing a list to this, and it's creating a series. Now one thing about series and data frame objects, they have indexes. Okay, and the indexes can be explicitly mentioned as well. You have the option of not mentioning the index. So in this case, the first case, it has you have not mentioned any index. So the series function has created default indexes 0 to 4. But in this particular case, you have mentioned explicit index. So if you look at this one, it has changed the indexes from the default values to the values that you have mentioned. So series object, although it is multi-dimensional, it has index values or index labels, and which can have a default value, or you can mention them explicitly. You can access the index values of a series object by using the index attribute, and the values separately using the values attribute. There is a lot of work that you need to do for your data science machine learning applications using missing values. Missing values are represented in Python as NaN, not a number. Okay, and they essentially indicate that they are missing values, right? And there is a lot of management of missing values that you have to perform in Python, and more so using series or data frame objects. Mostly in data frame objects, but sometimes when you have one-dimensional data in series objects as well. And here is an example where what we are doing is we are assigning a null value or a missing value to a particular element in the series that we have created, and it does this. It assigns through this statement, and in a subsequent statement we are dropping that. We are telling that, okay, drop all the elements in the series which have missing values, and that is achieved through this drop now function. And when I print the resultant series object, it prints this, which obviously missing the missing values, fortunately. Okay, I'll skip through quickly. We also have data frames to go through. So data frames, as I said, that also provided by Pandas, but they are essentially two-dimensional grids. Now I have a CSV file, an external CSV file, and what I'm doing is using the Pandas read CSV function, which automatically converts the data within the CSV file into a data frame. So when I print it, it's a data frame. This is how a data frame looks like. Okay. There are some dots here. That means that there are a lot of rows. So it is not printing because visually it is not going to be understandable. Now the first row of the CSV file are fetched as the header of the values. You can also create a data frame using a list of lists. So in this case, we are creating a list of lists, and it is creating it from here. So each of these lists within the parent list is pertaining to is creating one row of the resultant data frame. And here with the columns parameter, you are explicitly mentioning the column labels in this case. Okay, you remember that you can mention explicit index labels for series objects. Here in this case, the column objects. You can do a lot of things with data frames. So one such is grouping of values, grouping of the rows on particular fields, filtering of values, merging two data frames, just like you apply joins on RDBMS tables, create pivot tables using just like you do using Excel sheets, etc. So a lot of different types of complex operations are possible. We'll give a simple example of how you can conditionally extract rows from our data frame, and then we will move over to file and database quickly. Okay, so in this case, what we are doing is, notice the syntax. I'm not going into syntaxes very much. I'm just leaving it to you to understand the syntaxes and leaving it at the, just explaining at the concept level. So in this case, we are mentioning a condition, which is from this data frame, using this field, pick up all the rows where the engine size is greater than 2. So in your data frame, you have a lot of rows where engine size is less than 2, greater than 2, this is less than 2, etc., etc. And the resultant data frame has rows which are only more than 2. Now, one thing you have to remember is that this expression here, and I leave understanding the syntax to you, this expression here returns a data frame object. Okay, so this stuff getting printed here is a data frame object. So instead of printing it, so this expression prints it, but instead of printing, if you capture this the return value of this expression into another variable, that is going to be a data frame object. Okay, so with this I will stop and go to files and databases, and then at the end we will take a few questions. All right, now to start with file handling. So again, one case of file handling we have already seen in the previous Jupyter notebook, where we have imported an external file, imported data from an external CSV file, our car data, into using the read CSV function from Pandas library into a data frame. Okay, but we also may need to deal with a lot of textual data. They may not be in Excel format, they may not be in CSV format, etc. You may need to deal with flat files as well. So Python gives pretty strong features of dealing with files. So the conceptual thing that we have to remember is that you have a file name that has to be mentioned, and if in this case the syntax is pretty simple, because this is physically residing in the same folder as the Jupyter notebook is residing, so that is why I haven't mentioned the folder, but you can research and figure out about mentioning the folder subfolder structure in your environment when you have to mention a external file. Okay, not always in production cases or complex cases the files will reside in the same folder or dictionary as your program. The other thing that you have to mention is the mode in which you want to perform an operation, or the type of operation that you want to perform. So there are various types of file opening mode that are available. W means a write mode, and W also means that if the file is not existing, it will create it, and if the file is existing, it will override the existing contents. So you have to be very sure about what mode that you are using while opening a file. So the other thing is obviously a file has to be opened explicitly with the open command. If you want to write, use the write command, and you have to explicitly also close a file. Leaving a file closed open by mistake after your program is finished is not a good idea, because you are opening or you are creating a file object in the memory, and that file object will contain values or contents from your file in the memory. So if you leave it unclosed, some smart hacker may have mechanisms of tapping into your memory and access those contents. So explicitly just make sure that you close a file object. All right, so the open statement creates a file object with the file name and the reading mode. So I'm not going into every example here. You have write mode, as I explained. You also have read mode. The read command, if you want to read the content, you can use the read command, which kind of pulls all the content at one shot into into a variable, and then you also have an append mode. And in case of an append mode, when you use a write command, unlike the W mode, the write mode, the append will not overwrite the existing contents, but will add the content that you are writing after the existing content. So you can look at this code and do some own experiments in your free time with a physical file. All right, then there is the readline function, which reads one line at a time. You can also use the readlines command, which reads the entire file as a combination of lines at one shot. We also have an example of writing into a file from a DataFrame object. So you can try out this code. So here we are creating the DataFrame object. We are checking the content of it using a for loop and using the iter_rows function applied on the DataFrame, okay, which extracts one row at a time, and it actually returns two things. One is the index of the row, and then the row itself. And then we use a write command after opening the file explicitly using the W open mode, and we keep on writing the content from the data frame into it. Okay, and then we will look into quickly glance through a couple of examples of using a database table using Python. Now there are multiple steps that you have to use for using databases with Python. So one is in my case, I have used MySQL as my database. You have to install MySQL. Then you have to install. So there are some commands that I have mentioned here. pip3 install MySQL. So it installs MySQL in your environment. You also have to install a library called MySQL connector Python. So the connection that Python makes to the MySQL database is coming from this library. You can also install the MySQL workbench. Otherwise you have to use MySQL commands for creating databases, for creating tables. You have to use command line interface. If you're not comfortable with that, it is advisable to use MySQL workbench. So you can try doing all that. You have to start the MySQL database. You can do it from the workbench, or you can do it from the command line interface as well. And then comes the program part, the programmatic part of Python. So the first thing you do is you have to import the connector library that you have installed, and as part of the process you have to create a connection object first. Now the connection object, don't look at the password, although you can't get into my laptop anyway. The connection object is going to be used for executing any of the commands that you want to apply on the database and tables. Okay, so connection object establishes a connection, and it uses it needs a username, it uses a password, host IP address, and your database name. Then the second thing that it does is that you have to frame your SQL statements. So the first thing that I'm going to look at is create an insert statement and keep it ready. So in my insert statement, what we are doing is I have a toy database and I have a toy table to test it with, and I have these fields in the table, and I am inserting these values using the insert command in this table fields. Okay, so framing your SQL statement correctly as a string is very important, because a lot of times go on correcting syntactical mistakes. You will face it unless, I mean, there's a lot of single quote and double quote and triple quote, etc., etc., and then sometimes we miss out on the colon that has to tag with the SQL statement. Then you have to create a cursor. It's better to create a cursor. If you are familiar with RDBMS and the concept of cursor, very good. Otherwise, you can look up the concept of cursor. Cursor is essentially used as a wrapper for unit of work that we need to apply on a particular table. Okay, cursor is an unit of work that can be committed. Cursor or used to execute the SQL statements that we have. So in our case, what we are doing is we are creating a cursor and executing our SQL statement using the cursor. Okay, and then subsequently committing it, because if I execute the insert statement, it does not get committed. That means permanently affected in the table. You need an explicit commit statement on the connection using the connection object to make it permanent, make your changes, make your insert statement permanent. Then I'm printing. Yeah, so okay, so all good from here, and then I am fetching the records from my database table. Okay, so these are the rows that are there in my database table, in my student table. And what I want to do is, using my code, I want to print each of these rows. There are 3 rows in the table, and I want to print each of these rows in a formatted manner. Okay, so for that, I am doing a little bit of structured programming here. In the previous one, it's not so much of a structured programming. However, in this one, it's more of a structured program. I am using my code in a try block, and I also have an exception block which traps any error that are coming from the database table. And then at the end it is it will execute after the try block. It is going to execute the finally block. Okay, now what am I doing in the try block? I am forming my select statement. What I want to do is I want to fetch all the rows that are present in the student table. So I'm firing a select star, so I'm framing the statement, then I'm creating a cursor, and then I'm executing the statement. Now the cursor has a function called fetchAll, which is returning all the rows in the records object. Okay, now the cursor also has an attribute called row count, which returns after the execution. It returns the number of rows that are fetched. So when I'm printing it, it shows me 3. So row count is the attribute in the cursor which shows you all the number of rows that are fetched by your select query. Now after that, we are formatting the output a bit. All my records are there in the records object. What I'm doing is I'm iterating through the records object one row at a time. So as you know that I have 3 records in there, and for each row I am picking up the first element, the second element, and the third element, and the fourth element by using the indexes 0, 1, 2, 3, 4. And by using the indexes, what I can fetch is the values against each of the fields. So what are my fields? If you go to the top, you will see that student IDs, student name, stream, year of admission, subject 1, etc. These are the fields from the table. So when I'm using this construct row 0 within the square brackets, it is going to fetch the student ID for that particular record, and similarly it's going to fetch all the values from the from the rows and iterating one row at a time through the records object, which is storing all the records from the student table. Okay, and that is what it has done. Now after this is finished, it comes to the, if there is no error raised, it doesn't go into this block, the exception block. It comes to the finally block after executing the try block. So this is also one construct that's very useful for structured programming, that if you want to trap any exception from your program, that you can use this. So as I mentioned in the previous examples, working with files, it is better to close your file objects. It is also advisable, very highly advisable, that you close your connections and you close your cursor. So I'm explicitly closing the connection and I'm explicitly closing the cursor. So in production environment, if connections and cursors and file objects are open in the memory, it's not good news. It's you are leaving opportunities for hacking. Okay, so printing MySQL connection is closed, and this is how you are going to access. I mean, this is a simple example of working with database tables. Okay, so this is all that we had for this session.